Today we're continuing on with our trigonometry sections from last year. Yesterday we learned about degrees, minutes, and seconds and making the conversions into decimals. Today we're going to pick up with right triangle trigonometry with similar triangles. Now when we're talking about similar triangles, especially with right triangles, it means that we can set up certain ratios that are true for any triangles that have the same angles. I don't know why this is doing this. Hold on a second. Shut it off and try again. Really hasn't been my day today. Okay. Anytime we have a right triangle, which means it has the 90-degree angle in it, here and here, because it has those right angles in them, we know that if this triangle has a 34-degree angle and this triangle has a 34-degree angle, then these two triangles are similar. And what that means is that whenever we have similar triangles, that we have certain ratios that are true. So if I take this side A, which is the shortest side of the triangle, over C, the longest side of the triangle, that is equal to F, the shortest side of the triangle, over D, the longest side of this triangle. And that'll work anytime the triangle is a right triangle and it has a 34-degree measurement. Now, it's not just true for 34 degrees, it's any triangle that has both of those measures. A right angle and another, so this could be any other angle measure, like 60. If this one was also 60, then these two triangles would be similar and the ratios would be true. So the ratios hold for A over C equals F over D, B over C, or the middle length over the longest, would be equal to this middle length over the longest. And A over B equals F over E. So shortest over middle is equal to shortest over middle. Now that's all stuff you learned in geometry. I know that because, again, I was your teacher. All right triangles that contain a 34-degree angle are similar, so their corresponding ratios would be the same. That is always going to be true. These ratios will work for any angle between 0 and 90. That is our basis of all trigonometry. It all comes back to this. So if you understand this, then you know the basis for how trig is going to work for us. The hypotenuse of a right triangle is the side that's across from the right angle. The hypotenuse is always the longest side of the triangle. The adjacent side of a given angle, the one that's not the hypotenuse, this is for either angle that is not the right angle. Then the opposite side is the side of the triangle that is across from the given angle. You're going to see what I mean whenever I scroll down here. So if I have an angle C, which is our right angle, and I'm looking at angle A, that would be my given angle. So if I'm looking at angle A, then the side that's opposite of angle A is the one that is across from angle A. This side. That is opposite of angle A. The side that is adjacent to angle A is the side that's not the hypotenuse and is the one that forms the angle. So this side is adjacent to angle A. If I'm looking at angle B, then it's the opposite. For angle B, or this angle here, the side that's opposite of angle B is across from it. The side that's adjacent to angle B is the one that's not the hypotenuse that forms angle B. So A. A is adjacent to angle B. If angle A is the given angle, the adjacent side is B and the opposite side is A. If angle B is the given angle, then the adjacent side is A and the opposite side is B. Just summarizing what we learned. There are 6 possible ratios for the 3 sides of a triangle. These are called the trigonometric ratios. It's also a fun word to say, trigonometric. You'll remember these because of SOHCAHTOA. Now, if you had the greatest geometry teacher in the world, you probably learned this, like right at the end of the year. If you didn't have the greatest geometry teacher in the world, you probably didn't learn this, but something tells me you had one. The sine of theta, written as sine theta, this little thing here is a theta. It's a Greek symbol. That's the ratio. Sine theta is opposite over hypotenuse. So, sine opposite over hypotenuse. Cosine of theta, written as cos theta, is the ratio cosine theta equals adjacent over hypotenuse. That's where ca comes from. Cosine is adjacent over hypotenuse. And TOA is the tangent of theta, written as tan theta, is the ratio tan theta equals opposite over adjacent. So it's TOA. I'm not going back up. I realize I went through that kind of fast. Again, you've learned it already, but pause the notes. That's the advantage you have now over when we're in class. In class, you can't pause me talking. You know I never shut up. Also, fun fact, my microphone doesn't work in my room. So I'm carrying around this little baby mic, and it's got a wire on it. So if you hear me trip and fall, don't even laugh. In addition to those 3, the reciprocal of each is also a trig ratio. So the cosecant of theta is hypotenuse over opposite. And that's just 1 over sine. It's sine flipped. So sine theta is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Should make it a goal of yours to memorize these. Secant of theta, or secant theta, is hypotenuse over adjacent. That's 1 over the cosine of theta, or cosine flipped. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. And lastly is cotangent of theta. That's adjacent over opposite. And that's equal to 1 over the tangent of theta. Cotangent of theta is the opposite. Okay, now we get to evaluate the 6 trigonometric ratios of the angle theta. So I'm starting with angle theta. So it's all based off of this corner. Now the first thing that I would do is I would identify which side is opposite, which side is adjacent, and which side is hypotenuse. The longest side is the hypotenuse. The opposite side is across from it. Adjacent side is next to it. So now that we're looking at theta, let's start with our 6 trig functions. 6 trig functions: sine theta, cosine theta, tangent theta, and I have to do my opposites. Cosecant theta, secant theta, and cotangent theta. Almost got me. Okay, now I'm just doing what I know. Opposite over hypotenuse is sine. Tragic. That H is horrible. So that's 5 over 13, because 5 is the opposite. Cosine theta is adjacent over hypotenuse, and that's 12 over 13. Tangent is opposite over adjacent. So the tangent would be 5 over 12. Now, these 3 are my favorites. Move that cotangent theta over. These 3 are my favorites because it means I can look at this one, and if I did this one right, this is going to just be the flip. This can be a dangerous game, though. If I did this one wrong and I flip it, I got this one wrong. But luckily for you, I'm a genius. I don't got to worry about it. So this one is 12 over 5. Any questions on that? You'll have to meet me up in the Google Meet. I want you to try this next one on your own. See if you get it. If you can't, then watch how I do it. So I'm starting with theta down there. I have my hypotenuse, opposite, adjacent. Sine theta, opposite over hypotenuse, 1.6 over 3.4. Cosine theta, adjacent over hypotenuse, 3 over 3.4. Tan theta, opposite over adjacent, 1.6 over 3. Then I can switch them up. Cosecant theta equals 3.4 over 1.6, which, by the way, I should put the 1.6 over 3.4 in the calculator, because decimals and fractions, you don't really want to leave it like that. So we'll come up with a decimal answer for that. Secant theta, to do this one, you just flip it, 3.4 over 3. And cotangent theta, flip that, 3 over 1.6. And that's it. Okay, I will post an assignment for you. Again, feel free to get on Google Meet and see me if you need help. All right, that's it for me. I will talk to you guys later.